Hello everyone! So this is our second day of separable differential equations. On the first day we hit on several different examples and I wanted to expose you to a bunch. But now we need to practice a couple more examples and again highlight some different just characteristics and some different tricks that you might have to use as you face these problems. So the first one you're going to do mostly on your own, just to kind of review from what you did last time and make sure that you have it right, but then we definitely have to catch up on a piece at the end, and then the second one we'll do together. All right, so let's get started. Okay, so I just want to review the 4 steps that we went through that you have to do every time. And if you can memorize these steps and then go through the process, you'll make sure to not stop the problem too early and you'll make sure to get through all the way to the end. So first, separate the variables. So each side of the equation has only one variable. A lot of times we cross multiply for that and then we solve and we make sure that you have your dy on one side and your dx on the other. And of course, remember that the dy and the dx have to be in the numerator. Second, you're then going to integrate both sides with respect to the variable on each side. And you're going to add plus c to the x side. So you only have to add it to one of the sides and we're going to add it to the x side. Third, we're going to solve for that c value by plugging in that initial condition that you're given at the beginning of the problem. Last, you're going to plug c in and solve for y. All right, so let's go ahead and try that with this first example. Okay, so go ahead and get this copied down. We're going to have this differential equation, and we are asked to find the particular solution y equals f of x for this given differential equation with the initial condition that f of 0 is -2. What I'd like you to do now is pause the video and go ahead and do step 1. We'll kind of bring you back after every step. So go ahead and do step 1. I'll bring you back and make sure you got that right, and then we'll move on to step 2. Okay, so that first step was super easy. All you had to do was cross multiply, and in fact, you already have your variables isolated on either side. All right, second step, integrate both sides, and don't forget your plus c. So go ahead and do that now, and come back and check your answer with mine. Okay, so take a look at mine and compare it with yours. Hopefully we agree y squared over 2 for the left-hand side is equal to x squared over 2 plus x plus c. All right, next step, solve for c. Go ahead and plug in your initial condition, solve for c, and come back to me. Okay, so again, pretty simple stuff here. We plugged in the -2 for y, plugged in the 0 for x, and you should have gotten c as 2. Okay, last step is to go ahead and plug that c value back in and solve for y. So let's go ahead and do that. Okay, so check your work with mine here. So I plugged in my c value of 2, and then I needed to solve for y. So I went ahead and doubled both sides and got this line here. Y squared equals x squared plus 2x plus 4. To get y by itself, I took the square root of both sides. Now remember, when you take the square root of both sides, in an equation, we need that plus or minus in front of the radical. Okay, so we have to decide which one of those, because it's a particular solution, so you can't have options, one or the other. That's where your initial condition comes in. So we didn't do one of these like this in the first example, so I wanted to bring this up. If 0, -2 is your initial condition, that must mean that you have a point that when you plug in an x value, you get a y value back that is negative. And because of that, we are going to accept the negative square root as our answer. And if you were to check this, you could then see that in fact that's true. If you plug in the 0, you get negative square root of 4, which is -2. And that verifies that that is the correct equation, particular solution for that differential equation with that given initial value. All right, so that one was a pretty easy one, but I wanted to work through it with you because of that, that positive-negative piece, and that does come up from time to time, so I wanted to make sure to hit that with you. Okay, we're going to go ahead and do one more example together, and then we'll be done for the night. Okay, so our second example says, consider the differential equation dy dx equals x squared times y minus 1. Find the particular solution, y equals f of x, to the given differential equation with the initial condition f of 0 equals 3, which of course is the point 0, 3. All right, so let's get started. First of all, we're going to go ahead and separate those variables. So in this case, I'm going to multiply both sides by dx. So I'd have dy equals x squared times y minus 1 times dx. Now to solve for each of the variables on either side, we're going to go ahead. Remember, you do not ever divide by dx or dy. So we're going to have to divide away that y minus 1. So dy over y minus 1 is equal to x squared dx. All right, next step is to go ahead and integrate both sides. So, let's say the integral of, I'm going to write this as 1 over y minus 1 dy is equal to the integral of x squared dx. All right, so on the left-hand side, what do we need to do? Hopefully you're recognizing that we need to do a u substitution. Okay, so I'm going to kind of do that over on the side here. Okay, I scooched that over a little bit, so I had a little bit of room. So I'm going to go ahead and say that my u is equal to y minus 1. So du equals 1 dy, or just dy. So this is actually a pretty straightforward one. If I go ahead now and substitute that in, I'd have the integral of 1 over u instead of dy, du. So if I'm going to keep on with that left-hand side, the integral of 1 over u is natural log absolute value of u, which of course in this case my u was y minus 1, so natural log of the absolute value of y minus 1. All right, equals, and now the right hand side should be very quick. It's just x to the third over 3 plus c. So I'll bring that down here, x to the third over 3 plus c. All right, so step 2 is done. Step 3 is to solve for c. So I'm going to go ahead and use my initial condition of 0, 3, of the point 0, 3 here, and solve for my c value. So I'm going to bring that up over here, and I would say natural log of 3 minus 1. So absolute value of 3 minus 1 is just 2, which of course just stays as natural log of 2. And remember, that's important. Whether or not you had to change that coming out, whether or not you got a positive value plugging it in or a negative is important. So because we got a 2 and we kept it as 2, okay, I didn't have to change the value, that's going to matter later on. So keep that in mind. Okay, on the right hand side, I got to go ahead and plug in that 0 for x. So I just get 0 plus c. So I end up with c is equal to the natural log of 2. All right, so now I'm going to plug that back in and solve for my y value. Okay, so when I plug that back in, I get, let's see here, natural log, I'm just going to kind of draw a line here, natural log of y minus 1. We just talked about the fact that when I plugged in this 2 here, okay, when I plugged in my 3, so 3 minus 1 was positive, which meant that I did not have to change the value, didn't have to negate the value. Therefore, when I go to actually find my answer here, I can drop the absolute value and just leave it as y minus 1. So natural log of y minus 1 is equal to x to the third over 3 plus natural log of 2. Okay, at this point, I have a natural log equation. So if you remember what we did in class today, how do we go from natural logs equation to solving for that y value? And hopefully you're remembering that we are going to do an exponential. Okay, rewrite it as an exponential. Remember that, of course, hidden here in this right here is your base of e. And so if I take that e and I raise it to all of this, I get the y minus 1. Okay, so it's the lasso effect, or however you want to think about it. So I'm going to write this as e, need to get my pen, e to the x to the third over 3 plus natural log of 2 equals, now you just get the y minus 1. Okay, now I'm going to pause for a second and actually remind you of some exponent rules that you definitely need to use in order to simplify this another step further. So there is the exponent rule that is kind of reversed from how you learned it back in algebra. Okay, the exponent rule that you learned back in algebra that we are going to use here, we learned in algebra that if you have x to the a times x to the b, that you get x to the a plus b. Okay, so that's the way we learned it back in algebra. All right, well, I want to show you that in this case, we're actually going the other way. That if you have, we'll just use e so that it's clear for you. If you have e to the a plus b, which isn't that exactly what we have here? E to the sum of two things, okay? If you're looking here, we have the sum of x cubed over 3 plus natural log of 2. That we are in fact going to go in the reverse direction with our exponent rule, and we're going to recognize that that's the same as e to the a times e to the b. Why would that matter? Well, it's going to allow us to simplify this one less step. And this is really important. This is how they want you to leave your answers on the AP. All right, so I'm going to pick this back up, and I'm going to recognize that since this left-hand side is e to the, and I have a sum in my exponent, I'm going to rewrite that as e to the x to the third over 3 times e to the natural log of 2. That's equal to y minus 1. How does that help me simplify anything? Well, hopefully you recognize that this second term right here, okay, e to the natural log 2, that I can do some canceling. All right, e to the natural log of 2 can simply be rewritten as 2. So this is e to the x to the third over 3 times 2 equals y minus 1. So we have a couple last steps in order to finish this off. Okay, so my last step to solve for y now is just simply to add the 1 over. So I'm just going to rewrite this as 2e to the x to the third over 3 plus 1 equals y. And that's my final answer. And it's definitely more simplified than if I had left it as plus natural log of 2 up in that exponent. So like I said, this comes up quite a bit where they expect you to know and be able to perform this exponent rule kind of going backwards. So I really want to make sure you commit this to memory. Wouldn't be surprised if it was on an upcoming power quiz. And I want to make sure that you're able to use it then effectively to simplify the problem all the way. All right, so like I said, pretty short video tonight, but hopefully you're also spending time going over the other review video that I put out there. And I hope you have a great night, and I will see you in class tomorrow to practice some more of these. Thanks a lot.